My name is Nurul Balkis binti Muhammad Nawawi. So our group is choose a title of force convection heat transfer. So next we proceed to the objective of the experiment. So first it is to demonstrate the use of extended surface to improve the heat transfer from the surface. Next is to determine the temperature distribution along an extended surface. So we proceed to the procedure.
Okay, firstly we need to place the flat plate into the cup. And then power supply. Take the temperature ambient. Set the heater power control to 75 watts. And then allow the rise until 80 degrees C. Adjust the heater power control to 20 watts. And then wait 3 minutes. And then wait until temperature reading is obtained. Set the fan to 1.0 meter per second by using thermal anemometer. Wait to 3 minutes and then take the temperature reading. After that, set the thermal anemometer to 1.5 meter per second. Wait until 3 minutes again and then take the temperature reading. Now we will remove the flat plate. Install the pin plate, we will take the reading of the ambient temperature at the thermometer in the lab. Okay, we will take the ambient temperature here. Okay, and next we will set the heater power control to 75 watt and let the temperature at this thermometer rise to 80 degrees C. Adjust the after the temperature reach at 80 degrees C, we will adjust the heater power control to 20 watt. We will wait 3 minutes and record the temperature reading. After that, we will set the thermal anemometer to 1.0 meter per second and wait 3 minutes and record the temperature reading. Next, after 1.0 meter per second, we will change the velocity again to 1.5 meter per second using this thermal anemometer and wait 3 minutes again and record the.
Okay, next we place the feed plate. Set heat power control at 75 watts. And then allow the temperature rise to 80 degrees C. And then adjust the heater power control to 20 watt and wait for 3 minutes and then record the temperature. And then the reading temperature was recorded at 0.0 meter per second. Okay, and then set the fan control at 1.0 meter per second using the thermal anemometer. And then set 1.5 meter per second at this thermal anemometer. And then wait for 3 minutes and record the temperature reading.
Based on the result obtained, we can conclude that if the air velocity is increased, so surface temperature will be decreased, and it apply to the all plate. So this means it is inversely proportional to the surface temperature. So this can prove by heat transfer from an object can also be improved by increasing the surface area. So after we doing some result conclusion, so we can get the heat transfer. The most higher is free plate. From that, based on result and theory state, the objective were achieved, which is temperature distribution along the extender surface, and the use of extender surface will relate to the heat transfer.
Assalamualaikum warahmatullahi wabarakatuh. Now, I will talk about the application of free convection. Free convection is where any fluid motions occur by natural means such as buoyancy. Often, free convection not noticeable because of the low velocity involved. So now, the application is the warming up of a cold drink in a warmer environment by natural convection. So in this picture is a cold drink. In case cold drink, heat is transferred from the atmosphere to the drink, which is the high level to the lower level. So it will making the cold drink become warmer.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Balkis binti Muawalawi. Okay, now I will talk about the free convection of the cold drink. That's all.
Okay, next we will talk about the difference in density that occur in the natural convection. Okay. Even though we know that low density will rise and high density will sink, but for this case, as heat always flow spontaneously from hot to cold, the warm air will flow to the cold drink. It will push the cool air with high density from the cold drink. The cool air then mix with the warmer air and lose its density and become warm air. So it will rise here. Then it flow again to the cold drink, and this cycle repeated until the cold drink increase its temperature to the warmer temperature, to the room temperature.
Okay. As the conclusion, if the flow of air comes from the differences in density or temperature, it is called free convection, or also known as natural convection. Natural convection usually not noticeable because of it has a low velocity. Then we can conclude that the higher temperature will flow to the lower temperature. Meanwhile, the low density will rise and the higher density will sink. So this cycle will repeated until the food or the drink will warm up or cool down to get the room temperature. Okay, that's all. Assalamualaikum warahmatullahi wabarakatuh. My name is Nasriani binti Rahman. As we know, convection have two forms, which are free convection and forced convection. For the forced convection, we choose application of the fan. The process is known as forced convection heat transfer if the fluid movement is circulated by external energy device such as fan or pump. So when we need extra input or human input for that flow or heat transfer to take place effectively, so the fluid such as air is forced to flow over the surface. So we know that forced convection is related with the velocity, and the theory is the sweat that our body produce is for effective heat transfer. So second is So when the fan is off, the air around us absorb the water vapor until it saturated. So after that, it stop and we start feeling more hot. So last is, so when we switch on the fan, the air around us start moving. So the air never gets saturated completely, and hence the sweat keep evaporating by absorbing our body heat, and we will feel cooler. So that's all from me.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Nur Aisyah binti Arman. So the first convection is a special type of heat transfer in which fluid forced to move in order to increase the heat transfer. This forcing can be done by a ceiling fan, a pump, suction device or other. Many people are familiar with the statement that heat rise. This is a simplification of this different in density makes hotter material naturally end up of the top of cooler material due to the higher buoyancy of the hotter material. Okay, many people are familiar with the statement of the heat rise. This is the simplification of the idea that fluid are almost always less dense than the same fluid cold, but there are exceptions. For example, see the layers of the atmosphere and thermohaline circulation for exception. Okay.